Welcome to Ask and Learn.
To calculate the tension in each cable and the reaction at A, we need to draw the free body diagram for the beam to identify the forces. Now we have six unknowns over here: TCF, TDE, RAX, RAZ, MAX, and MAZ. The coordinates of the points are: the origin point A is 0, 0, 0, C is 80, 0, 135, D is 80, 0, 90, E is 80, 120, 0, and F is 0, 60, 135. Now apply the equilibrium equation. First, we need to locate each point with respect to A as follows. So in that term, we can write RDA is equal to 80I plus 0J plus 90K mm. RCA is equal to 80I plus 0J plus 135K mm. Also we have the vector DE is equal to 0I plus 120J minus 90K, and the magnitude of DE will be the square root of 120 square plus 19 square, that gives the result 150 mm, and the vector CF is equal to minus 80I plus 60J plus 0K, and the magnitude of CF will be the square root of 80 square plus 60 square, gives the result 100 mm. Also we can find from this the TDE, which is nothing but equivalent to TDE into DE vector upon the magnitude of DE, will be equivalent to TDE upon 150 into 120J minus 90K. And similarly, or we can solve it further. So it will give the answer TDE is equal to 0.8J minus 0.6K TDE. And similarly, we can find TCE is equal to, TCF is equal to TCF into minus 0.8I plus 0.6J. Now, as we know, sigma MC is equal to sigma R cross F is equal to 0. So let's take the cross product of R and F, which gives the equation MAXI plus MAZK plus 48 TCFK minus 108 TCFJ minus 81 TCFI plus 64 TDEK plus 48 TDEJ minus 72 TDEI minus 38,400 K plus 64,800 I is equal to 0. So this is the whole equation here for the R cross F. Now, as we know, sigma m is equal to 0, so we can equate the coefficient ij and k to the 0 individually. As the equation is very long, so first of all, let's do the exercise for the I coefficient. So we need to find out the I terms in this equation, which are max. So this one is also having I term. Another one is minus 81 TCF. So this term is having I term. Then minus 72 TDI. This one is having I term. And lastly, we are having 64,800 I term. So when we take the sum of all these terms and we are going to equating this to 0, this gives the answer is max minus 81 TCF minus 72 TDE plus 64,800 is equal to 0. Let's say equation number 1. Similarly, by comparing the coefficient of J, we will get TDE is equal to 2.25 TCF. Let's say equation number 2. And by comparing the coefficient of K, we will get the equation MAZ plus 48 TCF plus 64 TDE minus 38,400 is equal to 0. Let's say to equation number 3. Now we also know the sum of forces in the x direction give the result 0. So from this we can get Rax minus zero point 0.8 TCF is equal to 0. Let's say equation number 4. Similarly, we can do it for the forces in the y direction. So sigma Fy is equal to 0. So we will get from this the equation is zero point 0.6 TCF plus zero point 0.8 TDE minus 480 is equal to 0. Equation number 5. And by comparing the forces in the z direction, we will get sigma Fz is equal to 0. So we will have the formula Raz minus zero point 0.6 TBD is equal to 0. Let's say equation number 6. Now we are going to substitute equation 2 into 5. We will get the result. So we are going to substitute this equation number 2 into equation number 5, this one. So we will get TDE is equal to 450 Newton. And let's put this value in the equation number 1. So from equation 1, we will get max is equal to minus 16,200 Newton into mm. So we can write the full formula for the MA, which is MAXI. So MAX is here 16,200 I plus MAYJ, which is 0, plus MAZK, which is 0K, Newton into mm. Also, by using these values in the equation 3, in this equation, we will get MAZ is equal to 0 Newton into mm. And using these values in equation 4, here we will get RAX is equal to 160 Newton, and using this value in equation 6, this one, we will get RAZ is equal to 270 Newton. And lastly, from this we can write RA is equal to RAXI, that means 160I, plus RAYJ, which is 0, plus RAZK, which is 270K Newton. So finally we are having this RA.